I had a request from a subscriber called Sharaf Mansour who was asking me to do a video on attributes in C#. And as I so often do, I'm going to divide this into two parts. Next time, I'm going to be looking at how we can write our own attributes, custom attributes as they're called. But for now, I was just going to look at the basics of how to use attributes that are already there provided for us, because it's one of the most fundamental concepts in C#, and one that I find isn't always perfectly clearly explained. It's been there right since the beginning of the language back in the beginning of the millennium, but it's something that when I learnt it, it kind of infiltrated its way into my understanding. It was never clearly explained. So I'm hoping I'll be able to achieve that in this first video, and then we'll go on to look at writing our own. So let's just take a look at some code. And what I've got here is just a C# class declaration. And just like in pretty much any language, there are a set of keywords that we can use to somehow qualify any kind of declaration. So here, that class, I could say it was public, or I could say it was internal, and then I could also say something like it was abstract, or I could say it was static, or I could say it was sealed. A few others as well, but basically we've got a set of keywords within the language for how we can describe something like a class, and equally it applies to methods, to properties, to fields, and everything else. The language has what is of necessity a small and generally stable set of keywords, because we don't want the language to be changing under our feet. But as time goes by, people think of new ideas, new things that they want to do. And sometimes those features, if they're important enough, may get into the language, sometimes not. And that decision can actually vary from one language to another. So, for example, in pretty much all OO languages, we've got something like this. I could say private and then use the keyword static. And then let's just call this my int. So not always the keyword static is shared in VB, but the idea is there. We're saying that rather than having one my int per object, we're just saying we've got one my int for the entire class, for the entire system. There's only one of them. But then something that you sometimes want to do is a kind of in-between level where we don't have just one my int for the entire program. We have one my int per thread within the program, what's sometimes known as thread static. And it makes things safer because it means you don't have to worry about two threads accessing the data at the same time because they've each got their own copy. Now, if we were writing in C++, so we've just got a quick C++ example here, then that is actually done with a keyword. So I could say thread local static int my int, and that would achieve that job. So that's a keyword in the language that is saying one per thread, not one for the whole system. But if we look back at the C#, actually there is no C# keyword to achieve that. That is done with an attribute. So we actually say thread static, and there we can see our first example of the attribute syntax, that we put that in square brackets and it applies to that int. And it achieves the same thing, but because it's a kind of a borderline case, it does it not by extending the language, but by extending this system of having attributes. In that case, it was a situation where C# didn't have the keyword. It can work the other way as well. So here's another example. Something we looked at in an earlier video, and I'll pop up a link to that, was the idea of extension methods. And the way we can do that in C# has to be in a static class, and then we could have a public static string, let's say, and the example we had in that earlier video was converting to kebab case. Doesn't matter about the details of that, but remember the way we did this in C#. We say this string original, and then just to keep it happy, won't put any actual functionality in there, but we'll just return a blank string. But the point is that this keyword is what is saying that this is an extension method, and the type that it extends is, in this case, string. If we're doing that in, say, VB, so I've got another language here, just for excitement, we do it slightly differently. So we have in VB a module, that's the equivalent of a static class, but then in here I could do something like public function to kebab, and then that would take a parameter of original as string, and then it would return a string, and then again let's just get that to return blank just to keep things happy. But we don't have the ability in VB of putting the this keyword, or it would be me keyword if it was the close equivalent, but it doesn't work like that. In VB, this has to be done through an attribute. And so we use angle brackets for attributes in VB, and then here we could actually say extension, and that is an attribute that is specifying that this is an extension method. So it works slightly differently. We saw one case with thread static where it was decided in C# not to be a keyword, not to be a language feature, whereas with extension method it is, but not in VB. Worth noting though, when you have an attribute, it is defined in a library somewhere. In the case of something like thread static or this extension, they are defined as part of the .NET library, but in other ones we'll see later they may come in third-party libraries or even ones you've written for yourself. If we take a look at the definition of it, so just hit F12 there, we can see it is actually a class that derives from a base class called attribute, but the odd thing about it is the class itself is called extension attribute, and it's a convention that's pretty much universal that you always follow the name of an attribute class with the word attribute when you're declaring it, even though when you're actually using it, you drop that off. So we've got extension attribute, we've got thread static attribute is what it actually comes from, but we don't use that when we're actually making use of it. Now, the thing about it being in a library means it's available to multiple languages. So you might think, therefore, we could actually, in C# also use that extension attribute. And you can see it's there. It is picking it up from system.runtime.compiler services. But it's then giving us an error basically saying, this is C#, you don't need to do that because we've got the this keyword. So although attributes are available in any language because they come from a library in .NET, that doesn't mean that the compiler for every language has to interpret them, and it could ignore them, but better, at least it gives an error in that case to tell us the right way to do things. So that's a couple of examples of situations where we've got attributes. We can see in those cases, they were attributes that were understood by the compiler, but the compiler is only one of the tools that is allowed to interpret attributes. They can also be understood by the runtime system or by third-party libraries by code we write for ourselves. Another example, and I think this was probably the first example I ever saw, was actually serializable. So we put serializable on a class if we want the serialization system to be able to store it in a file or send it to a stream or something like that. All that that is actually doing is it is giving permission for the serialization code to access your private data. So if we had a private int myint, serialization uses reflection, which is perfectly entitled to access that myint, but we've declared it as private, so it shouldn't really, and so kind of out of politeness, it won't do it unless we've explicitly put that serializable on there to say we're doing that. Now, serializable actually is quite an interesting example because if you look at another language, yet another language, in this case Java. Now Java nowadays does have the equivalent of attributes. It actually calls them annotations. You'll find different languages do call these things different things. So we've got attributes in C#, annotations in Java, you've got decorators in TypeScript, but they're all basically the same idea. But the original version of Java didn't have these annotations, and what it used to indicate something was serializable was what's actually known as a marker interface. And so what you did in Java was you would implement an interface called serializable. Java doesn't use eyes to indicate as a naming convention, so it's just called serializable, but it didn't have any content at all. It was completely empty, and its purpose was there purely so that the runtime system could use reflection, look at that class, and see that it had implemented the serializable interface, and that was a clue, basically, to say, yes, whoever wrote this code wants it to be serializable. But it's clearly hijacking another mechanism. That is not what interfaces are there for. Interfaces are there to provide methods that you have to implement. So just using it as a marker was better than nothing, but it really was a bit of a cheat. Another way that you might have done this, and some really old languages do this, is purely by a naming convention. So you could simply say, well, if we have a class that ends in the word serializable, then that is the way we indicate that we're intending this to be serializable. And you could make that work, but again, it becomes very messy because then your class names get longer and longer. What if you've got multiple attributes? You just get a huge name. So that's why the approach of using attributes is a better way to go. And occasionally, you'll see people in C# using this idea of a marker interface that doesn't do anything except provide the sort of information that you'd rather have in an attribute. But generally speaking, attributes are a better way to go. Now, another thing to mention about attributes is the way that they are targeted. And in most cases, the example we've seen here, an attribute targets the declaration that immediately follows it. So here we're saying we've got serializable immediately before the declaration of some class, so it is some class that is serializable. Here we've got the thread static immediately before myInt, so that is the thing that is thread static. And in most cases, that is perfectly clear. That's how you do it. But there are a few examples of situations where it's not that simple for the compiler to work out what you're applying the attribute to. So we have this ability to do specific targeting. So, for example, I could, if I wanted to, actually put here type : serializable. And that means we are applying the attributes to a type. The type is a class or a struct or an enum or an interface, things like that. It's completely unnecessary here, so you'd never see it done, but that's what you've got. And you've got various ones of these. So another attribute we have actually related to serialization, there is non-serialized, which basically says although the entire class is serializable and therefore all of the properties would by default be serialized, we can say, oh, but not this one, I don't want that one to happen. And in that case, that is applying to a field. So again, unnecessary, but we could say field : non-serialized, and that would just make that clear. But the situations occur where the compiler can't work that out for itself. For example, if instead of having a private field, what if we had written a auto-implemented property? So let's call this myInt. Now, remember what's happening there, although it's very simple in terms of code, we've got the situation that that is generating a getter, a setter, and what's known as a private backing field where the data is actually stored. And if we did that and had it as serializable, as we have it here, then that backing field would be automatically part of the serialization. It'd be written to the stream, read in, which you probably want. But if you didn't, you'd again want to put on that non-serialized. But as soon as we do that, here we get an error because it's basically saying that you can only apply non-serialized to fields, and here we're trying to apply it to a property. So we'll see this more when we write these for ourselves, but every time you write an attribute, you have some specification, if you want, as to what it can be applied to. And non-serialized can only be applied to fields. And so this is the situation where that's really useful, because now I can say field non-serialized, and what we're saying is no, don't apply it to the property, apply it to that auto-implemented backing field that's hidden away inside there. Other situations where you might want to do that, although you've got these targets for almost everything, the situations where you need to use them, there is return. So if you want to apply a property to return value, you can do that. You don't need to do it for parameters, because for parameters you can just put the attribute directly on there. So field and return are useful. And then the third one that I find useful sometimes is assembly, because as well as applying attributes to classes, fields, properties, we can apply them to the entire assembly. And obviously that wouldn't make much sense in terms of putting it before something, because you can't put it before the assembly. And the way we can do this is simple enough. Anywhere in your code within the assembly, we can put an attribute, and we just use another of these targeting words, so we can say assembly and then whatever the name of the attribute may be. And wherever that is, as long as it's in some of the code in your assembly, that will be regarded as an assembly level attribute. So that's some examples of attributes that are part of .NET itself. So all of those, although they're used in different places, some by the compiler, some by the runtime system, they are all part of the standard .NET library. An example where we're going to start using something different is actually when it comes to testing. So let's go to this test project. And in this case, we are using the Microsoft Visual Studio testing. So that's still Microsoft. It's not part of .NET itself. And equally, it could have been something like XUnit or NUnit or something completely unrelated to Microsoft entirely. So what we can have here is we have the idea that in the Microsoft testing environment, you use the test class attribute to mark that this is a class containing tests. And then we have the test method attribute. And then in here, we can just do public void some test. And it doesn't really matter what's going in there, but you can see there we've got our test method. And then these attributes aren't looked at by the compiler. They are looked at by a third party, again, Microsoft counts as a third party, plugin in Visual Studio, and are therefore used, if we go to the testing, to search through the code and find which methods are intended to be tested. And there we can see we've got that listed there, and then ultimately to run the tests. And that's something that we could do for ourselves. We won't do exactly that next time, but you'll see how we could write our own attributes, write some code that can then look at the classes, look at the code, and get those attributes out of there. The reason the testing is quite a nice example, though, is because we can also see a really nice additional feature of attributes that really wouldn't work in those other ideas I had of using a marker interface or using a naming convention. Attributes can take parameters. So let's suppose actually this is a test for addition. And I might do something like this. It's very silly, but it shows the idea. We could have an assert r equal, and then I could do 3 and 2 plus 1. Okay, so we're only really testing the plus operator in C#, which we know works, but that would work. But the problem with this is it's only one example. And so if you only had that test method, we might have to call that addition 2 and say 30 is 20 plus 10, and it gets really very tiresome. So what we actually do is in all of these testing frameworks, we can have the equivalent of this. In Microsoft, we call it a data test method. And then we can have int A, int B, int result. And then we can simply have a test for result equals A plus B. And then we can provide as many examples as we like. So here I could do 1, 2, and 3. And then I could do another one, 10, 20, 30. And if we run those, they should all pass. But you can see we've now got multiple tests based on the one method, because we've also got these attributes that can take these parameters. So the fact that attributes can take parameters is another very useful feature that we'll be looking at when we write our own. But it's really where they become very powerful indeed. That does lead us on to one interesting little problem here, which is something that seems like a very natural extension of this is, what if we wanted to do this for a different type? We might want to do it for doubles, which will actually work fine, but another one we might want to do it for is decimals. So decimals in C# don't really look very different from doubles or ints or other things like that. Remember, we can indicate that these things are decimal literals by putting an M on the end, but actually immediately we do that, we are getting a bit of a problem, because it's saying, not very clearly, an attribute argument must be a constant expression, type of expression, or array creation expression of an attribute parameter type. And it's that attribute parameter type that is the problem, because decimal is not one of those. If we just take that back, and then also, just as another example, let's put in a data test method that in this case has a data row that's taking a string. Thing to notice here, that data row is just taking a parameter type object, so anything could go in there. So that's not the problem with decimals. And then let's just put in public void some test that takes that string, doesn't matter what it is. But the thing I want to show you, if we build that, and then if we bring up the ILDASM, the Intermediate Language Disassembler, and drag into that the DLL, so there's our tests DLL, and then take a look under tests and look at, say, addition, then we can see that in amongst all the other information it's got in there, you can see there is our data row attribute and the two examples and their hexadecimal encoding. We've basically got those values that we had 1, 2 and 3, 10, 20 and 30. If we take a look at the string one, we can see in this case it's got the attribute, and there we can see it's got the hex, and in this case actually showing us that that has a value hello. But the problem is, this is what is known as metadata, data that can be embedded in the DLL as information about, in this case, the method. And we are restricted that metadata can only refer basically to fundamental types, which are ints and doubles and some things like that. Strings count, but decimals do not. Decimals, although they are a primary data type in C#, although there's a keyword decimal, they are implemented actually as a struct in the .NET library, not as a fundamental type. And that's why they are not allowed, and it's a bit of a problem you can hit, because it would be so nice in our test code if we could just have what we had there of putting in those decimals, but you're not allowed to do. You can have ints, you can have doubles, you can have strings, but not decimals. Various tricks we can do to get around it. Let me just show you one of them. So what we can actually do is here we say we want dynamic data, and then somewhere else in the class we specify that data. It's a bit fiddly in terms of types, but what we have to do is we actually declare public static, and then we're going to make this an array of objects. And the reason we want to do that is we need multiple parameters for the equivalent of each data row, so that's one of the arrays, but then we need multiple data rows, so that's why we have an array of arrays. So we'll see, we will get one array for 1, 2, 3, one array for 10, 20, 30, and so forth. We'll give that a name that we're just going to call data, let's say, and then we make that a get-only property. It's going to return a new object array, and then we can just fill in the values that we want. So our first row is going to be a new object array, just the one dimension to it, that's going to be initialized to 1m, 2m, 3m, and then the next one we'll have as 10, 20, 30, and as many as we like. And then here on this dynamic data, we just reference the name of that data. So we could have written it as a string, but it's always safer to use name of. And so there now, you can see we are allowed to have our decimals, because the only problem was we couldn't have decimals directly in the attribute because it wasn't allowed in the metadata. But now the only thing in the metadata is the name of data. So if we rebuild that and then go back to our ILDASM and pop it in there once again, we can now see, if we look at that addition, that the only thing contained in the metadata is just that piece of text data. We are allowed strings, remember, and so it's not a problem. We've got the decimals in there, but they haven't been embedded in the metadata. So that was just a specific example, but I thought it was worth mentioning there because you need to be aware when you're writing attributes that you're only allowed this limited set of types in there, and it does hit a problem when we're dealing with unit testing, but there's a relatively easy way around it. And there are very, very similar equivalents to that in XUnit and NUnit and so forth. So that was a quick look at the basic ideas of attributes, why they're there, why they can be counted as language extensions to some extent, but because there's so many of them, you wouldn't want them in the language itself, and so they can be processed by the compiler or by third-party tools, or, as we'll see next time, you can write them for yourself and write a tool to do that processing for you. So I hope that was helpful. Do click like if you liked it, do subscribe, and do come back next time to see how you can write your own attributes.